Hi, everyone. Hope you're doing well. Today in class, we did this really fun activity with Angry Birds and using Desmos, but I'm going to summarize it here for you, those of you that missed it or those of you that need some extra help. All right, so let's jump right into our notes. You are going to title this Quadratics. It's the unit we're in right now, and we're going to talk today about this thing called LOS. LOS stands for line of symmetry, or you can also sometimes refer to it as axis of symmetry. So let me show you what I mean. Here I started to draw a coordinate plane, and in class today we did this little game with Angry Birds. Like, let's say we had a bird right here. It's this game that you used to be big about 10 years ago. But what you do is you would, on a computer, you would take this bird and you would launch him up and over like some obstacles, and you're trying to hit another bird. Like in our example, there's this green bird that was sitting over here kind of on a pedestal. And so the game is you try to launch the bird and to knock out these other guys. And the bird follows this interesting path where it like goes up and then comes back down. This is created by what we call a quadratic. This shape is actually called a parabola. A parabola is a curved line on a graph, and in this case, it's going up and then coming back down. And so what I'm going to do is I'm actually going to sketch this in a little bit more solid now. This is the path of the bird, and it follows a parabola. Now, so there's some interesting things about parabolas. Notice that there's a peak to it, like a top. It looks like the top is somewhere like right around here. This is what we call a vertex. It's the maximum amount that the parabola reaches, or in this case, our Angry Bird reaches. And there's this other interesting thing where if I were to draw a line right through the vertex and down, it looks like I'm splitting the parabola in half. That's what we call a line of symmetry, or its axis of symmetry. It's a line, it's a mirror image of itself. The parabola is a mirror image of itself on both sides of the line. So today we want to focus a lot on this LOS and how to find it. And this is what it means. So now we'll talk about how to find it. So let me show you an example. I don't have the equation for this quadratic, but you did use it in class. But let me give you a different example. Let's say we had 2x squared plus 5x minus 4. So here's a quadratic, and if we made it into an equation or a function, we could actually graph it. So let me just create an equation with it. We'll call it y equals. So as x changes, we're going to be keeping track of the y's, and what it would do on the graph is it would create this curved shape. Sometimes they curve downwards like that, or they go reverse, where it like goes down and then back up, where it curves up. All of them are going to have this reflection point, this line of symmetry. And there's this really great formula you can use to find it. The formula for a line of symmetry is x equals negative b over 2a. If you run that formula, you're going to find the line of symmetry. A is whatever value is in front of your x squared, b is in front of the x, and c is over here at the end. So in this quadratic, I can find the line of symmetry by plugging in, substituting some of those numbers. So it's going to be x equals negative b, which is 5, over 2 times a, which is 2. So now I simplify that. I get x is negative 5 over 4, or it might be more useful to write it as negative 1 1/4. So on the graph for this one, where x is negative 1 1/4, so like over here, that's the line where the parabola reflects itself. And there's some really useful ways we can use that, but we'll talk more about that later. Today, your purpose, I haven't talked about that yet, your purpose is to be able to find the line of symmetry. So here I found the line of symmetry for this quadratic. Let's do another one. We can also write this in function notation. Remember, we learned function notation a long time ago. F of x is the same as y equals. It's just another way to keep track of your function. So let's say we had negative 3x squared plus 8. And if I'm finding my line of symmetry, I'm going to use x equals negative b over 2a. Now, I notice my a is negative 3. I don't have a b term in this one. I don't have an x. So my b would be 0, and my c is the number on the end, and 8. And notice we don't really use the c in the line of symmetry, but you do use it for something later on, so I'm still keeping track of it. In this case, my x would be negative 0 over 2 times negative 3. So I can already tell this is going to be 0, right? 0 divided by anything is 0. So this is where my line of symmetry is. It would be right where x equals 0, which is right here. So this parabola actually reflects itself around the y-axis. All right, let's do one more. Let's do negative x squared minus, oh, you know what? I forgot to make it a function or an equation, so let's do that first. I'll do the y equals. So y equals negative x squared minus 3x plus 2. So again, it's creating some sort of curved parabola, and the line of symmetry is going to be at negative b over 2a. In algebra 1, you don't have to be able to create that. You don't have to know where it comes from, but we will talk about it later, and you do need to know how to use it. Now, in this case, my a is in front of the x squared. Remember, it's not the actual variable, it's the number in front. There is no number in front, though, but there is a negative sign. So this would be negative 1. My b is negative 3, and my c value is 2. So now, for my line of symmetry, it's going to be negative 3. So that just means positive 3 over 2 times negative 1. So if I simplify that, I get x is 3 over negative 2. X is negative 1.5. That's kind of similar to the answer we had before on a different one, but still different. So that again is the line where the parabola reflects itself. And it's nice to know that, because when we have to create these lines, since you know they're mirror images of themselves, you only have to do kind of half the work. If you know where this line is and you figure out everything on one side of it, well, then you know what's going to be on the other side. It's just a reflection, kind of what was going on with the Angry Bird here. What was going on this side of the parabola reflects itself over here. And I could continue drawing out his path kind of like that. And you can see it's just this curved parabola that continues the entire way. So that's how you find the line of symmetry, and it will help you in your homework. Okay, so good luck with all that, and I'll see you guys next time. Okay, bye everybody.